All right, let's work through. This is review worksheet number 3, 9.7 to 9.10. Number 1, find the radius and interval of convergence for this series here. So interval of convergence, radius, usually with these series, we use the ratio test since everything's already in terms of exponents that we see. So with the ratio test, we do a limit as n approaches infinity for a sub n plus 1 divided by a sub n. So a sub n plus 1, we just replace every n we see with n plus 1. And then divided by a sub n, which is the same thing as multiplying by the reciprocal. So times 3 to the n times n squared, all over x minus 2 to the n. And then we look to see what we can do to simplify and reduce and cancel out. So x minus 2 to the n plus 1, we can write it as x minus 2 to the n times x minus 2 to the first power. The x minus 2 to the n will cancel out, leaving us with x minus 2. 3 to the n will cancel out, leaving us with just 3. And then the n plus 2, n plus 1 squared, and n squared will stay. And then really this is the only portion that will change. So as n approaches infinity, we see that this expression will have the same degree, numerator and denominator. We just take the leading coefficient, which is just going to be 1. So we're left with just x minus 2 over 3. Absolute value of x minus 2 over 3 is less than 1. Now we're trying to get this into the form of x minus c is less than r, right? So we're almost there. Just have to multiply both sides by 3. So once we have that, then we have x minus 2 is less than 3. So we know the center is at 2, and then the radius is 3. So if we think about it that way, if the center is at 2 and radius is 3, then that means our radius of convergence must be between -1 and 5. So absolute value of x minus 2 is less than 3. That's the same thing as saying x minus 2 is between -3 and +3. And if we add 2 to both sides, we're going to have -1 and 5. So we have the radius of convergence. The interval of convergence would require us to have to test the endpoints. So I put bracket and parentheses on both of the endpoints to indicate that we have to test each of these endpoints to determine whether we're going to have brackets or parentheses at these endpoints. So again, radius is 3, center is 2. We have to test -1 and 5 into our rule of sequence. And then if we put -1 into our rule of sequence here, replace every x we see with -1. -1 to the n stays. X becomes -1, so -1 minus 2 is -3 to the n over 3 to the n times n squared. Notice that -1 times 3 will just be 3 to the n, and 3 to the n cancels out, leaving us with just 1 over n squared. 1 over n squared is a converging p-series, so we know that that at x equals -1, the -1 is included as our interval of convergence. So -1 is included. So we know we'll put a bracket around -1. We have to test 5 now. So if we plug 5 into our rule of sequence here, we get 5 minus 2, which is 3. -1 to the n, 3 to the n, all over 3 to the n times n squared. The 3 to the n cancels out, leaving us with -1 to the n over n squared. Now this is still going to be a converging series because it's a p-series. However, it's alternating series, so because of the numerator alternating signs between positive and negative. So all that requires for alternating series is 1 over n squared will go to 0, and it does. So we know that the series will converge at 5 as well. So we know the series will converge at -1 and at 5. So our inverse convergence is bracket -1, 5, bracket. Okay. Part B here, we have the summation of 2n quantity squared times x minus 5 to the nth. We can go through ratio test. So we're going to add do a sub n plus 1 divided by a sub n. So a sub n plus 1, we're going to add 1 to the n. So 2 parentheses n plus 1, the same thing as 2n plus 2 factorial, times x minus 5 to the n plus 1. So this is a sub n plus 1 divided by a sub n. And if we reduce, we're going to get this down to 2n plus 1, sorry, 2n plus 2 times 2n plus 1 times x minus 5 to the first power, or yeah, to the first power. Limit as n approaches infinity for this expression will go directly to infinity. So we know that there are three options. Either our interval convergence is at for all real numbers, for certain values, or only at the center. So here, this tells us that this series will not converge for any other value except for the center. So series will converge only at the center, c equals 5, since there are no other values of x that will cause this to go to 0. All right, number 2, we have our rule of sequence, x to the n over 2 to the n. We're trying to figure out the interval of convergence again. So we have exponent. So with all these problems, pretty much we're going to be using ratio test to determine the radius of convergence and also the interval of convergence. So we have a sub n plus 1. So here's a sub n plus 1 divided by a sub n. That's the same thing as multiplying by the reciprocal. So here we're left with x over 2. So limit as n approaches infinity of absolute value of x over 2 is less than 1. So if we multiply both sides by 2, we know that x will be between negative 2 and 2, or absolute value of x is less than 2. So if absolute value of x is less than 2, then that's the same thing as saying x is between negative 2 and positive 2. So now we just have to test the endpoints. Test to determine whether negative 2, whether the series converges at negative 2 and positive 2. So we have to plug negative 2 into our rule of sequence. So negative 2 to the n, replace every x we see with negative 2. So negative 2 to the n over 2 to the n. Here, the same thing as we can take out a negative 1 to the n. Then if that's the case, then 2 to the n cancels out. We're left with negative 1 to the n. Now, negative 1 to the n will diverge by the n-term series test, n-term test, because if we find a limit as n approaches infinity for negative 1 to the n, it will oscillate between negative 1 and 1, and will never converge. This series will never converge at a specific value. All right, so n approaches for x equals 2 for now. If we plug 2 in for the x value of our rule of sequence, 2 to the n over 2 to the n is 1 to the n. This will also diverge by the n-term test, since this rule of sequence will not get closer to 0. It'll stay at 1. So, and we think about the series, right? 1 plus 1 plus 1 plus 1. This will not converge. It will keep increasing to infinity. So that means our interval of convergence will not include either of the endpoints. So therefore, parentheses, negative 2 to 2. All right, part C. Use the first three terms of the series to approximate f of negative 1/2. So here's our rule of sequence. If we write the first three terms, we always start off with whatever the starting value they provide or is provided in the rule of sequence. So plug 0 in for n. So x to the 0 over 2 to the 0, which is going to be 1. Next we plug in 1, so x to the first power over 2. Next we plug in 2, get x squared over 4. So here we have the first three terms. We're going to use the first three terms to approximate the actual value of the function at negative 1/2. So plug negative 1/2 into our rule of sequence, or into our polynomial, into our polynomial approximation. So we get 1 minus 1/2 plus 1/16. We get 0.8125, or 13 over 16 with our calculator. Part C, estimate the error involved in the approximation in part B for f of negative 1/2. So when x is equal to negative 1/2, notice that here, well, first off, we know that this is going to be a converging series here. Really, x over 2 to the n will increase faster than x to the n, since x is just going to remain at a constant. So we know this is a converging series. Next, we also know that this is a series that is alternating signs. So if it's a converging alternating series, then the maximum error is going to be the first unused term. So if we look at the first unused term, the next term up will be x to the fourth over 2 to the fourth if we plug in n equals 4. So x to the fourth over 2 to the fourth. So x to the fourth over 2 to the fourth, if we replace x with negative 1/2, we're going to have 1 over 64, right? And we know the error cannot be greater than 1 over 64, so that will be our maximum error. And then to show that work here, we have 1/2 actually 1 over 16 divided by 1 over 16. Yeah, 1 over 64.